What property of light determines the color that you see? It is frequency. So of all the properties of light, no, it doesn't matter what color you write with. There will be times where it'll be helpful to use certain colors. Like I said, we're going to use red, blue, green, yellow the most often, but occasionally I'll use some of the other ones. All right. So frequency, how often the waves happen. So the order or the frequency that light waves happen determines what color it is that you're going to see. All right, so what's the order of visible light from low to high frequencies? So the lowest frequency is going to be red. After red comes orange. No, this is the only time I'm going to use orange. You can write it just in regular, like you don't have to do it in colors. Red, orange, yellow, green. Yep. Blue. Now, blue is this color. Blue is a light color. Blue is literally the color of the sky. The sky is what blue actually is. Okay? If you look at the books that we have in this class, they are not blue. Those books are indigo. Now, most times people combine these together and just say they're both blue. Now, for what it's worth, I'm going to use indigo a lot of times for my blue just because I need blue to be a different color because I don't have that other color, so I'm just doing the best I can. And then lastly would be violet. Like purplish, yeah. Let's see, is this actually... Okay. Yep. Roy G. Biv, your good friend, Roy G. Biv. Yep. You guys haven't heard of... I thought that was common. That would actually explain why all the rest of the periods just looked at me with a dumb look on their face, like, yeah, sure, Roy G. Biv, whatever you say. Yeah, so Roy G. Biv. Okay, so what determines the color of an object? So frequency determines what color you see. So if I look at something and it's yellow, so I look at this folder, and this folder is yellow. Or if I hold up this folder, this binder is green. So what determines what color I see? It has to be the color of light that's reflected. So I have to see that color. So it's the frequency of light reflected. What determines the color of an object? The frequency of light that is reflected. Frequency of light that's reflected. So whatever color you see has to get reflected off of the object. So if something is red, it's reflecting red. If something is blue, it's reflecting blue. Whatever color you see of an object, that's the color it reflects. So let's talk about the primary colors, okay? Last period disappointed me. We'll see if your period disappoints me or not. Primary colors are, I heard, red, blue, and green. Red, blue, and yellow. Red, blue, and green. Okay, let's start with this. I'm being a little deceptive because I wanted you guys to get it wrong. You guys picked two options. One of those is right. I should probably be more specific. What are the primary colors of light? The primary colors of light are red, blue, and green. Now, we'll come back to yellow, because yellow is going to come up again. But the primary colors of light are red, blue, and green. Okay? Those colors are red, blue, and green, and I'm going to show that to you here in just a second. So, if you're in the front row, go ahead and stand up. Bring your paper with you. Or I'll leave it to you as an option. I'm going to go back over these as well. So if you just want to watch the example and not worried about writing stuff down, just leave your paper at your desk. If you're a person that wants to write things down as you do it, then bring your paper with you. Otherwise, if you're in the front row, stand up, go to one of the back tables. If you're in the middle row and you'd like to see better, go ahead and go to one of the back tables that's open or one of the side chairs. But I'm going to be using that screen back there. So, when we looked at the demo, so what is white really when you talk about the color white? It's not really a color. It's all primary colors combined. And really, when we're thinking about it, we're adding them. Okay? So what is black then? We said black was when you absorb the primary colors. Instead of combined, let's say reflected. I think that's a better. Well, you can leave it then, but reflected is probably a more accurate depiction. All right, so what is black? Black is all primary colors absorbed, which would be subtracted. So you take out the colors as opposed to adding the colors. So the white paper is reflecting all of the colors here. The white paper is reflecting all of the colors. But the black ink is absorbing all those colors. So that's why the ink looks black and the paper looks white. All right, so what happens to the primary colors of light when you mix them? All right, so here are my primary colors. Here is blue. There's blue. Here's red. And here is green. All right, so blue. All right, so blue by itself is blue, obviously. Red by itself is red, obviously. And green by itself is green, obviously. Okay, but what happens when we start combining these? So when I combine the red and the green, in between them, I get yellow. Okay, when I combine the blue and the green, I get cyan. And when I combine the blue and the red, I get magenta. And obviously, where they all overlap, I get white. I'll give you a sec to catch up here, because I just did a lot of stuff. Should we get paint? What? Correct. If you mix paint together, it's always going to get closer to black. It's never going to get closer to white. Why? Because it's subtractive. We'll talk about that in a second, actually.
So is that why the center of all three lines looks white? Is that why the center line looks white?
Yeah. When we're talking about visible light, again, this is light, not paint. So when we add red, blue, and green light, we get white.
Oh, because we're adding matter. Nice one.
Correct. You're talking about like paint and stuff? Yeah, you're mixing together pigments, and we said pigments take the light out. And so when you start taking more light out, they get closer and closer to black. Okay. All right, so what are the color subtractive primaries? How they mix? Well, we already talked about the main primaries. So the primary colors of light, red. The hugest question?
Yeah.
Red, blue, and green. What?
How was white paint? Yeah.
I actually don't know that. I'd have to look that up. I'd have to look up how
Because
white paint
others
is
don't
made.
all the colors been mixed.
My guess is you're creating a paint without any pigment in it. So it's not actually absorbing any light. It's just reflecting light. No, put it away. We'll look it up later. Put it in your pocket. Put it in your pocket. Good. Just making sure. Just making sure. Okay. So if we absorb out red, that means we don't absorb out blue and green. And if we don't absorb blue and green, those combine to be cyan. Okay? If we take out blue, that means we don't take out green and red. And if you don't take out green and red, when they reflect off an object, you get yellow. And when you subtract out green, you're left with blue and red. And blue and red together make magenta. That is how paints work. So, if I take cyan, which gets rid of red, and if I take yellow, which gets rid of blue, and if I take magenta, which gets rid of green, if I take all of those out together, then I'm going to be left with black. And that's number 10. What do you get when you add all subtractive primary colors? You get black. Because they subtract out all the colors. They subtract out all the primary colors and you got nothing left. We'll get there. So let's talk about why that yellow sheet looked the way it did. So if I have a yellow object...
Teachers and students, pardon the interruption for a few announcements here at the end of the day. First, tomorrow night's Student Government Movie Night.
This is going to be great on YouTube.
Students, you can please check your Schoology messages to see when that has been rescheduled. So again, Student Government Movie Night postponed for tomorrow night. I want to wish the following groups good luck here tonight. Our baseball at Victory Field against Carmel. Our boys and girls track and field at the Zionsville Invite. Here at home, come and support our softball team. We have a senior night versus Terre Haute North. And we are also hosting our spring dance recital in the auditorium. So come and support our dance program. And good luck to our symphony orchestra in their state qualifier this evening. And tomorrow, our girls tennis hosts the Avon Invite. We want to wish our wind symphony, our Allegros and attraction, as well as chamber singers and accents all good luck at state qualifiers for hopefully moving on to state next weekend. But good luck to all those groups tomorrow. Everyone have a great weekend. Thank you.
All right. You're welcome. So, why does yellow look red in red light, green in green light, but black in blue light? So, red light hits yellow. Yellow is a combination of red and green. So it reflects off of yellow, and what you see is just red. So it's going to look red to you. Okay? Green. Green is a combination of, or green is part of yellow along with red. So if green hits the yellow surface, it's going to reflect off. If you're looking at it, you're going to see green. But blue is the one that's absorbed. So when blue hits the yellow, nothing reflects, and it's going to look black. Remember, black is all light absorbed. Well, if the only light is blue and you absorb it, then the color is going to be black that you see. So white and black are a little bit different. All the rest of the colors are based off of frequency. White and black are based off of what colors are reflected or absorbed. Okay. We'll do the eye. We'll do the eye next time. We'll do the eye next time. I can't wait to post this on YouTube and then have like the end of the video being like Mr. Shockley talking, giving announcements. Should I have that on there? Like and subscribe like a boss!